Hey friends, this video is to help you in regard to your quantum numbers. Quantum numbers can be thought of as a set of coordinates, like map coordinates almost, for every single electron in an atom. Every electron has its own particular set of quantum numbers, and no two sets are alike. That's how we can distinguish one electron from another within an atom. All right, now as I already said, there's four numbers involved. The first one is known as N, and it refers to the principal quantum number. This is the main level that that particular electron finds itself. It could be 1 to infinity. Now, we know we only have, at this point, 7 periods worth of elements. So really, it could be 1 through 7. In other words, your electron may be on principal level 1, principal level 2, and so forth. Okay? The second one is the angular momentum quantum number, known as L. It's okay. Really and truly what we're talking about there is which sublevel is that electron. So you have the main level and then a sublevel, right? We already know about these, S, P, D, and F. Well, the L number can be anything from 0 to n minus 1. Let's look at it this way. Suppose I have an electron and it's on principal level 2, okay? Principal level 2. So my N number would be 2. My L number could be 0 or 2 minus 1, 1. Either 0 or 1. Now, the L values correspond with the different types of sublevels. 0 gives us S, 1 gives us P, 2 gives us D, and 3 gives us F. In other words, if I have principal level 2, that means that my sublevels could be either 0 or 1, S or P. You see, just like we already knew, on principal level 2, we have our choice of sublevel S or sublevel P. Okay? Starting to get the hang of it. So, principal level 3, I could have anything, an integer from 0 to 3 minus 1. So, 0, 1, or 2. And on principal level 3, we find that we have an S sublevel, a P sublevel, and a D sublevel. Is it starting to make sense? Hope so. The next number, the third in our set of 4 numbers, is the M sub L. Now, you could really think of this as the particular orbital that that electron finds itself in. All right, remember that, for example, the P sublevel has 3 orbitals, right? So the orbital number can be anything from negative L to positive L. All the integers from negative L to positive L. All right, let's go back to our previous example. We had principal quantum number 3. We had 3 possibilities then, 0, 1, or 2, 0 to n minus 1. It could be S, P, or D. Let's say that it was on the P orbital. Well, if L equals 1, then M sub L could equal negative 1, 0, or positive 1. Negative 1, 0, or positive 1. You get it? So if that electron was right here, in this middle one here, we'll do like this. And let's say we're asking about this particular electron right here. We would say that its first 3 quantum numbers could be 3, and then the L sublevel would be P, so 1 and 0. Now it would have one more number that we haven't gotten to yet, but that's the last number, which is known as the spin number. Remember how we have an up arrow and a down arrow? They have to have opposite spins. Now we've assigned a value of positive 1/2 or negative 1/2 to these spins. Those are the only 2 numbers that M sub S, this final number, can be. So if you have a question and it's asking you about which of the following are legitimate sets of quantum numbers, if you have one of them that ends in anything other than positive 1/2 or negative 1/2, it's a no-go. Those are the only 2 values for that last number. So let's say in this case, we had this situation. I might call this 3, 1, because it's p orbital, 0, and then let's just say positive 1/2, because it's going upwards. Okay, you get the idea? Let's do another example over here. I've drawn an orbital diagram, and we can see we go up through the 4s and the 3d sublevels here. So we're going to talk about that particular electron right there. What would the quantum numbers be for that particular electron? Okay. First of all, we can see it's in the 3rd energy level. So that's my first quantum number, 3. Next, we find that it's in the D sublevel. All right? We saw over here that our designations are 0 for S, 1 for P, 2 for D. So therefore, the second number would be a 2. But now, which orbital is it in this D sublevel? Remember, we said that the orbitals could be integers anywhere from negative L to positive L. If my number is 2, if my L number is 2, that would be negative 2, negative 1, 0, 1, and 2. Negative 2, negative 1, 0, 1, and 2. You get it? So what's my number there? Negative 1. And then finally, I just need to add a spin number. Is it positive 1/2 or negative 1/2? I'm going to choose positive 1/2. I just kind of do that because it's pointing upward. Okay? So positive 1/2 for my last number. And this would be my set of coordinates for that particular electron. By the way, if I had another electron facing down in that same orbital, in that same sublevel, I would call it 3, 2, negative 1, negative 1/2. Like we said, no two electrons have the same exact coordinates. Okay? So that's how quantum numbers work. Again, we said that the first number corresponds to the main level that that electron is on. The second one corresponds to whatever sublevel it's in. And we said that the values of L could be any integers from 0 to n minus 1. So if n equals 4, we could have all 4 sublevels, right? 0 to 4 minus 1, or 3. So we could have all 4 of these, and we know that to be true. The next number is the orbital number. It could be anything, an integer from negative L, the previous number, to positive L. By the way, that's also how you can tell if a set is invalid. Let's say I had 3, 2, 3, and negative 1/2. Well, right here, there's a problem, because this third number can only be as great as the number previous. It has to be negative L to positive L, right? Since it's greater than positive L, this is a no-go. All right, so that's the way we can tell if a set of numbers is inaccurate. All right, and then the last number, of course, pertains to the spin. It can only be plus or minus 1/2. All right, guys, hope that helps. If I can help you any more, let me know.